Welcome back to the Fan Showdown, Season 3, Episode 3 this time, and I'm hoping that you guys notice some much needed visual improvement of the episodes and hopefully all other content on the channel after this. I've made some behind the scenes overdue changes to my camera equipment, long overdue, and I'm hoping it translates into like a better experience for you guys. If it does, or you just like the Fan Showdown, make sure to click the like button so I know that things are moving in the right direction. I think the record is 35,658 likes from Season 2, Episode 3. That's like the record for a Fan Showdown video, so I think we can beat it. Let's give it a shot. Now, if this is your first Fan Showdown, welcome. And how this works is you guys out there kind of design what you think is the coolest, strangest, funniest fan design, and you send it to me. I print them out, we test them in the A12X25 body, and we kind of just enjoy the creativity of the community. It's pretty good. Satisfaction guaranteed, performance is not. If you want to get involved in the Fan Showdown, make sure to get subscribed, head down to the description. I have all the information you need to figure out the design constraints for your fan, where to send the file, what file type to send, and maybe we'll see you in a future episode. Now let's see what we got today, right after this. Thank you to Digital Storm for sponsoring this video. Digital Storm's passion is chasing performance. Their motivation is delivering the world's most advanced PCs. With 20 years experience, their computers are built from the ground up with unmatched engineering and thermal design. Combine that with industry partnerships featuring the latest technology, and they can deliver incredible power and performance that's trusted by enthusiasts, gamers, and content creators. Digital Storm is committed to improving their craftsmanship to drive a better customer experience. Each PC is handcrafted with attention to detail, including the placement of individual components and the routing of cables to improve airflow and upgradability. Building a PC is only part of the journey. Digital Storm is proud to back every customer with lifetime support from their team of in-house experts. Customers are family, and they're dedicated to resolving issues as quickly as possible. So if you're looking for a great experience, a great machine, and peace of mind, choose Digital Storm for your next PC build. Check the link in the description below, and thank you again to Digital Storm for sponsoring this video. Now first up, we have the Noctic fan, which was created by Andrew, and this is interesting for two reasons. Those being, I think, the Noctua A12X25 and the Arctic P12. Andrew said that he took two of the best fans, in his opinion, and combined their blade design into one fan. This is interesting because I don't think we've seen anyone take this kind of approach before when designing, their own fan. As for design, it does look cool. It printed pretty easily, which I'm always appreciative for. The only concern that I do have is the blades are very, very thin, which is normally not a bad thing, but based on how the blades are shaped, you got a lot of mass towards the outside, so I'm fearful that they might do a little bit of twisting as it spools up. But we'll have to give it a shot and find out. Now this next fan shouldn't have any flexing issues, that's for sure. This is the Oval Blade Boy, or OBB, and it was created by Craftcentric. Craftcentric said that they set out to create a Bernoulli ring repeated a few times, and the idea was to end up with like an airfoil wedge shaped cylinder that's kind of collapsed. Now Craftcentric said that they didn't get exactly what they set out for, but I do think it looks pretty cool. And as long as it moves some air and keeps the CPU from throttling, I think you nailed it. Also, again, another fan that printed very well, no support needed, good contact area, didn't have any peeling issues. All in all, when a fan prints well, it makes me happy. Now this next one is one of the thickest boys yet. This is the Hectopod 1, and it was created by Ricardo.
Hi, I'm Duke's biggest lady I've ever seen.
Ah, that's a huge bitch.
The inspiration for this fan came to Ricardo while he was watching the movie Arrival. And if you haven't seen it, it's about like a spaceship that lands on Earth and like humanity is trying to figure out ways to communicate with these weird creatures within it. It's a pretty good movie, I think. But that's where the inspiration for this fan came. To me, it looks like the inspiration for the fan was that one scene where one of those aliens like pushes its hand thing against the glass. If you took like that hand and you kind of twisted it a little bit, I think that's exactly what this fan would look like. Also as a bonus, I know I've said it twice, this printed really easily as well. This is probably the easiest one of the bunch. Maybe the easiest one actually I've ever printed. It has a humongous contact area and a very shallow overhang, so there was literally no problem printing this. Now I've saved the most complicated for last. We've already covered 3 fans. This next fan is a fan comprised of 3 different parts. This is the cheater, and it was masterminded by Nesto. You can probably guess why Nesto refers to this fan as a cheater, but if you ain't cheating, you ain't trying, so I'll allow it. Now, as you can see, the cheater is broken into 3 parts. parts, or 4 if you consider that the fan disc is comprised of 2 parts, or maybe more than that because each blade is a part, but semantics. The first being what Nesto calls the splitter, but you might recognize it as the velocity stack, or a velocity stack. We've seen these used before on the channel, and they actually work really well. The main goal of a velocity stack is to smooth and even out the air flowing into the intake, also known as laminar flow. After that smooth air enters the fan, it interacts with the next part of his design, which is the fan. Now, Nesto went above and beyond when he created his fan. Normally, as we see and how I've done it in the past as well, is we print the fan as one unit, or design it as one unit and print it out as one big part. But that doesn't mean you have to do it that way. This fan is broken into 2 parts. The first part is the spinner, which is very important if we want to maintain that laminar flow that Nesto is going for. And then after that, we have 5 blades with progressive pitch that slide into little grooves that are made in the spinner. And once everything's installed, I had to go then back and glue it all together. And the glue that I normally use, actually I always use for gluing my PLA, is called Weld-On 4. I've used it in the past for acrylic. It's really meant to weld acrylic together. But for some reason, it works really good with PLA, and I've used it for a long time, and it's very thin, so it seeps into the cracks and joints really easily. And that's what I used to glue this fan together, and it worked phenomenally. Now the last component is what Nesto's calling the diffuser. The job of this part is to maintain that smooth flow. Think of like the Noctua AAS that we made in that one video, and how we were able to cool that CPU at such a far, far distance. Assembling all this together, we get an absolute unit. Now, you out there might think that this is cheating, hence the name, but I would call it clever engineering. But I don't know, what do you guys think? Do you think this is cheating? Do you think we should allow it? What are your thoughts? I kind of like assemblies like this, but I don't know. Let me know in the comments, I guess, what you think. Well, let's see how they sound. The cheater came in at 49.6 dBA. The OBB came in at 47.7 dBA. The Hectopod came in at 48.1 dBA. And the Noctic came in at 44.6 dBA. Now this is where we should talk about something that we ran into with the Noctic. Our concern was the blades and how thin they were, and as you noticed in probably some of the B-roll, the RPM was very low on this fan, and that's because I had to kind of slow it down. Any faster than 1070 RPM and the blades themselves started contacting the shroud, and then it would just kind of grind to a halt. So turned it up as fast as I could get it before they started touching, and 1070 was as fast as she could go. Now it still moves air, so it still should cool the CPU, but how much air is it moving? I don't know. We're gonna have to take a look. Now in the smoke test, you can tell that the Noctic is at a bit of a disadvantage due to its rotational speed, but we're still pushing air, so it still should perform. The Noctic finished with an average temperature of 88.1 at a room temperature of 20.5, giving us a delta of 67.6. The OBB finished with an average temperature of 78.7 at a room temperature of 20.6, giving us a delta of 58.1. The Hectopod finished with an average temperature of 82.9 at a room temperature of 20.6, giving us a delta of 62.3. And the Cheater finished with an average temperature of 76.6 at a room temperature of 20.6, giving us a delta of 56. Placing the Cheater in first, the OBB in second, the Hectopod in third, and the Noctic in fourth. But more impressively is that overall, the Cheater has pretty much crushed every single other fan that we've tested on Season 3, and it even edged out the A12X25. But also, the OBB, it got third overall, which is something I actually didn't expect. So, although you didn't nail the design you were going for, you made something pretty cool looking and actually something that performs pretty well. But once again, thanks to all of you guys that watch these videos, click the like button, everybody that subscribed to the channel, everybody that has sent me a fan, even if you haven't seen it on the show yet, without you guys sending me all these crazy designs, this is obviously not possible. So remember to click the like button, get subscribed, share it with your friends, and we'll see you in the next one.